Welcome to qnawire.
What is the range of possible perimeters P of the given figure A, B, C, D, E if AC equals 5 and DC equals 9? In this question, we are asked to find the range of possible perimeters of a shape using the lengths of two sides and a given figure. We can start by adding the two lengths we are given. We are told that AC is 5 and DC is 9. We can also see in the figure that side BC has the same length as side DC, and side AC has the same length as side CE, so we can add these lengths onto the figure. We can then recall that the perimeter of a polygon is the sum of its side lengths, so the perimeter P of the given polygon is equal to AB plus BC plus CE plus ED plus DC plus CA. We can then substitute in the known side lengths from the figure to obtain that P equals AB plus 9 plus 5 plus ED plus 9 plus 5. We can then simplify the right-hand side of the equation to get that P equals AB plus ED plus 28. We now need to find upper and lower bounds for the two unknown side lengths. We can do this by noting that both sides are in triangles with two known side lengths, so we can apply the triangle inequality. This tells us that in any triangle, the sum of any two of its sides' lengths must be greater than the length of the final side. Applying this to each pair of sides gives us three inequalities that must be satisfied for any triangle. Applying this result to triangle A, B, C in the figure and using the known side lengths gives us three inequalities. We have 9 plus 5 is greater than AB, 9 plus AB is greater than 5, and AB plus 5 is greater than 9. We can rewrite each of these inequalities to isolate AB. In the first inequality, we have 14 is greater than AB. We can reorder this inequality to get that AB is less than 14. In the second inequality, we can subtract 9 from both sides to get that AB is greater than negative 4, though we already knew this since AB is a length. We can subtract 5 from both sides of the third inequality to obtain that AB is greater than 4. We could apply this same process with triangle CDE. However, we can note that the two known side lengths in this triangle are the same length as those in triangle ABC, so we would obtain the same inequalities. In particular, we want an upper and lower bound for DE, so we want the first inequality that tells us DE is less than 14, and the third inequality that tells us DE is greater than 4. We can now note that AB and DE must both be less than 14, so we substitute 14 for these lengths into the perimeter formula to find an upper bound for the perimeter. Similarly, we can substitute AB and DE equals 4 to find a lower bound for the perimeter. Substituting 14 into the perimeter equation and writing the inequality gives us P is less than 14 plus 14 plus 28, which simplifies to give us that P is less than 56. Substituting 4 for the lengths in the perimeter formula and writing the inequality gives us that P is greater than 4 plus 4 plus 28. Which simplifies to give us P is greater than 36. We can combine these inequalities into the single compound inequality 36 is less than P is less than 56.